Imagine being lost in the middle of nowhere, and a tiny device in your pocket guides you back home. That's the magic of GPS technology. GPS, or Global Positioning System, is a network of satellites orbiting Earth, beaming down signals that help your GPS device pinpoint your exact location. It's changed the way we navigate our world, making it possible to find our way in unfamiliar cities, track our workouts, and even find the nearest pizza place. Now, aren't you curious how this seemingly complex system works in such a simple and seamless way? At the heart of GPS technology is a network of satellites orbiting Earth and beaming down signals. But what does this network look like? Imagine 24 satellites strategically placed in 6 different orbits around our planet. These orbits are designed to ensure that no matter where you are on Earth, at least 4 satellites are visible in the sky above you. Now, these satellites aren't just floating aimlessly in space. They're on a mission, constantly transmitting precise coded signals. These signals are picked up by GPS receivers here on Earth, perhaps that smartphone in your pocket or the navigation system in your car. Each of these 24 satellites carries an atomic clock, and this is where things get interesting. You see, these clocks are incredibly accurate. We're talking about a margin of error of less than a billionth of a second. This precision is crucial for the GPS system to function correctly. As these satellites orbit Earth, they're moving at speeds of about 7,000 miles per hour. Despite this speed, the signals they send out travel at the speed of light, taking mere milliseconds to reach the surface. Your GPS receiver picks up these signals, noting the exact time it was sent and the time it was received. Now, you might be wondering, why does the receiver need to know the time the signal was sent? Well, by comparing the time a signal was transmitted by a satellite to the time it was received, your GPS receiver can calculate how far away that satellite is. And with signals from at least 4 satellites, your GPS receiver can pinpoint your exact location. So these satellites are continuously transmitting signals, but how does your GPS device know where you are? The secret sauce of GPS technology lies in decoding these satellite signals. But how does it all work? Let's start with trilateration. This is not just a fancy term, but a crucial process that helps GPS devices determine your exact location. Picture yourself in a vast open field with no landmarks in sight. Now imagine 3 satellites beaming signals from space. Your GPS device receives these signals, each carrying a timestamp that reveals how long it took for the signal to reach your device from each satellite. Now the GPS device performs some calculations. It knows the speed at which the signals travel, roughly the speed of light. By multiplying the time it took for each signal to reach the device by the speed of light, it can calculate the distance between the device and each satellite. But knowing the distance isn't enough. So let's add another layer to this. Imagine 3 spheres, each centered on one of the satellites. The radius of each sphere is the distance from the satellite to the device. Now, these spheres intersect at one point. Your location. Sounds simple enough, right? But there's a catch. The precision of this process relies heavily on the accuracy of the timestamps in the satellite signals. And this is where atomic clocks on board satellites come into play. These clocks are incredibly precise, ensuring accurate timekeeping that's crucial for the trilateration process. But even with precise clocks, other factors can cause slight inaccuracies in the signals, such as atmospheric interference and gravitational potential. To correct these, systems like the differential GPS are used. With these signals and some clever math, your GPS device can pinpoint your location, but is it always accurate? Like any technology, GPS isn't perfect, but it has a way to correct its inaccuracies. Now let's delve into how GPS overcomes these inaccuracies. The method is called differential GPS, or DGPS for short. So what exactly is DGPS? It's a system that helps correct errors in GPS signals caused by various factors. One such factor is atmospheric interference. Think about it. The signals transmitted by the GPS satellites have to travel through space, penetrate the Earth's atmosphere, and then reach our GPS receivers. During this journey, the signals can be affected by several elements such as atmospheric conditions, which can lead to inaccuracies in the GPS readings. Here's where DGPS steps in. DGPS uses a network of fixed, ground-based reference stations to broadcast the difference between the positions indicated by the GPS satellite systems and the known fixed positions. These stations receive GPS signals, calculate the inaccuracies, and then transmit a correction signal to the GPS receivers. The receivers then use this correction data to correct their own calculations, thereby improving the accuracy of the GPS data. This continuous process of checking and correcting ensures that the GPS system maintains a high level of accuracy, even when faced with factors that could potentially disrupt the signal. So, next time you use your GPS, remember the network of satellites, the decoding of signals, and the constant effort to overcome inaccuracies that make it all possible. GPS technology might seem complex, but at its core, it's all about signals and location. We've journeyed through a network of Earth-orbiting satellites, a marvel of modern technology that continuously transmits signals to GPS receivers. These receivers, like the one in your phone or car, decode these signals and use a process called trilateration to calculate your precise location. We've also delved into how this system overcomes inaccuracies. Factors like atmospheric interference can distort GPS signals, but through ingenious solutions like differential GPS, these inaccuracies are corrected, ensuring you get the most accurate location data possible. Moreover, the GPS is a global endeavor, operated by various countries with their own global navigation satellite systems, all cooperating to ensure compatibility and precision. From GLONASS in Russia to Navasi in India, these systems work together to guide us in our daily lives. And that's how GPS works, guiding you from point A to point B and everywhere in between.